Hello everyone, as you know we are dealing with acidic nature of phenol. For further comparison, this question must be answered. How plus R and minus R effect of substituent can decrease and increase the acidic nature of phenol? Topic is involved for 12th, JE, NEET and BSc. Let's start. First I am going to show you plus R effect. The plus R effect of substituent. Number 1, plus R effect of substituent will always decrease the acidic nature. Note it down. Now what is plus R effect? Loss of electron by substituent during resonance. If your substituent is donating electrons during resonance, means it is showing plus R effect, and that plus R effect will decrease the acidic nature of phenol. For example, if I have one normal phenol and if I have a phenol with NH2 group. Now NH2 group will show plus R effect. It's a substituent and it is showing plus R effect. So out of these two, it will be less acidic. Plus R effect of substituent will decrease the acidic nature of phenol. So it will become less acidic and it will be more acidic. Now which substituent can show plus R effect? Already I have told to you. What are the sign? Atom which is directly attached with benzene ring if carrying lone pair. So such substituent will show plus R effect. Now how plus R effect will decrease the acidic nature of phenol? Let's check. I have already told to you the acidic nature can be checked by two ways. The first way was check strength of OH bond. In OH bond, you know, electrons are shared between oxygen and hydrogen. If by any factor electrons are going toward oxygen, so bond will become weak and release of H positive will become easier. So acidic strength will increase. And if by any way electrons are going away from the oxygen, means towards center point, so the bond will become strong, release of H positive will become difficult, means acidic nature will decrease. So let's apply it. This concept video already I have provided to you. Please check it thoroughly. I'm going to apply it. This is normal phenol and I am making a substituent over here, this one. OCS3, ether functional group it is. Now you know how to draw a resonance. Once you will finish the resonance of normal phenol, you know how to do it. Electrons will come here, pi electrons will move further and next movement like this. Already I have drawn this phenol resonance. But you know the substituent, this substituent which is carrying a lone pair, which is directly attached with the benzene ring, also able to show resonance. First be careful with the position. It is on ortho position. It's a ortho position. Okay. So how it will show resonance? Like this. first movement, due to which lone pair will come here. When oxygen will deliver lone pair here, these pi electrons will feel repulsion and they will move to next carbon. On this carbon, vacant orbital will generate. Vacant orbital will be filled by lone pair, means a dative bond will be generated between oxygen and carbon. So oxygen will carry a +1 charge because out of 2 electron, 1 electron completely transferred toward carbon. Now, this is the case which we need to study. Now, as you can see, due to plus R effect, this is plus R effect. Means our substituent is showing plus R effect, means donating electron due to resonance. After this plus R effect, you can check electrons are coming on this carbon on which OH was attached. Check. So definitely these electrons will affect the strength of OH bond. How? If these electrons are coming on this carbon, so definitely these electrons between carbon and oxygen will feel repulsion and they will move little toward oxygen side, due to which the electrons which were toward oxygen due to higher electronegativity of oxygen, they will also feel repulsion and they will start to move toward central point. And what I said, if electrons are moving away from the oxygen, the bond will become strong. So this bond will become strong. If bond is becoming strong, release of H positive will become difficult. Difficult release of H positive will decrease the acidic nature. Means this compound will be less acidic. And you can check why it has happened. It has happened due to plus R effect of the substituent. Because of its plus R effect, the electrons are coming on this carbon directly. Check. Due to these electrons will feel repulsion and they will move toward oxygen. And as they will move toward oxygen, these electrons, shared electron between oxygen and hydrogen, will also feel repulsion and they will start to move away from the oxygen. Means they will start to go toward central point and the bond will become strong. Strong bond, difficult to break, difficult release of H positive ion will make this whole compound less acidic. So from ortho position, substituent which is showing plus R effect will decrease the acidic nature of phenol. Let's change the position. Meta position. If I draw resonance from meta position of a substituent, this will be the first position. Next. This is second structure. Next. This will be the next structure. Next. Oxygen will get its pair of electron back, so positive charge will finish and resonance is completed. You can check during this whole resonance, electrons are not coming on this carbon to which OH is connected. Means from meta position, OCH3's plus R effect is not going to affect OH group. So we will say from meta position, from meta position, plus R effect is not working or not operating. Note down. Means from meta position, if substituent is showing plus R effect, it will not affect the acidic nature of OH group. Let's try on para position. They will come here, repulsion will felt by these pi electrons, and obviously they will shift to next carbon. One lone pair will left. Next structure will be this. Yes, check. From para position, this plus R effect of OCH3 is able to produce electrons on this carbon to which OH is attached. So definitely these electrons will make these electrons to move toward oxygen due to repulsion. And as these electrons will move little toward oxygen, these shared electrons will feel repulsion and they will start going away from the oxygen, means towards center point of the bond. So bond will become strong. This OH bond will become strong. As it will become strong, release of H positive will become difficult. So the acidic nature of this group will decrease, means it is less acidic. Means the point is, conclusion is, plus R effect from ortho and para position, plus R effect of substituent from ortho and para position will decrease the acidic nature of phenol, not from meta position. Because from meta position, the plus R effect is unable to create lone pair on the carbon to which OH is directly connected. In this fashion, plus R effect will decrease the acidic nature of phenol from ortho and para position, not from the meta position. Second way, if you want to test, second way was check stability. Of anion left after removal of H positive ion. The plus R effect from ortho and para position will destabilize the anion left after removal of H positive ion. Check. This is the second technique which I am going to apply. These both methods I have informed to you. Okay, this is a group. Obviously it will show plus R effect, but here I don't want to check strength of OH bond. I want to check stability of anion left after removal of H positive. So let's remove H positive. This will be the anion which will generate here. Already told to you how it will generate. When it will break bond from hydrogen, both electrons will shift toward oxygen and oxygen will carry -1 charge. Now this oxygen is unstable already. This substituent will make it stable or unstable. Let's check. Due to plus R effect, you know this way resonance will come. And look at the position, ortho position it is. You can check due to plus R effect of this OCH3 group, electrons directly coming on the carbon to which O negative was connected. Now what will happen? These electrons which are present on the carbon, obviously due to these electrons between carbon and oxygen bond will feel repulsion and they will start to move toward oxygen side. And as they will move toward oxygen side, the negative charge of oxygen will increase. Means here, negative charge of oxygen is increased. And if negative charge is increasing, means the stability of an ion is decreasing. So, stability is decreased by plus R effect of substituent. Means this anion is unstable. So, this particle knows that after loss of H positive, I will get an anion which is destabilized by the plus R effect of a substituent. So it will be little bit hesitate itself to deliver H positive. That's why release of H positive will become difficult and this compound will become less acidic. So by both ways you can check the acidic nature. Check strength of OH bond or check the stability of anion which is left after H positive. Now this effect can be operated from ortho as well as from para. But from meta, electrons will not come here, so there is no effect on the stability of O negative ion from the meta position. So same, like we have checked for strength of OH bond. Means the conclusion is the plus R effect of substituent from ortho and para position will decrease the acidic nature of phenol. Now let's go for minus R effect. Minus R effect of substituent. Now first of all, minus R effect of substituent will increase the acidic nature of phenol. What is minus R effect? Gain of electrons due to resonance by substituent. Let's check. First of all, which substituent can show minus R effect? Already I have told you the condition. The atom which is directly connected with benzene ring should not have any lone pair. Secondly, it should be connected with more electronegative with the help of pi electrons, like NO2 group, nitro group. Nitrogen do not have any lone pair connected with benzene ring. You can check 4 bond it is making. Secondly, it is connected with oxygen which is more electronegative than nitrogen with the help of pi electrons. So it will work as a substituent which can show minus R effect. Now first method I am going to show you. Strength of OH bond. How minus R affected substituent can decrease the acidic, can increase the acidic strength. Check strength of OH bond. This is normal phenol and I am going to add a substituent on a ortho position. Now this substituent is going to show minus R effect. What is minus R effect? Gain of electrons due to resonance. How they will gain electron? Check. This phenol is going to show resonance like this. This is the first movement. If I am not writing any charge on any lone pair, so please draw them by yourself. Now, understand this point. Already the electrons between oxygen and hydrogen were toward oxygen side because oxygen is more electronegative than hydrogen. Suppose this is a central point. Already electrons are toward oxygen side. Now after resonance, you can check oxygen is carrying +1 charge. So due to this positive charge, don't you think these electrons will come more close toward oxygen? Shared electrons. Means the bond will become further weak. The bond is already weak due to resonance of oxygen. Now, you can check here we have a role of nitro group. After resonance, the electrons are on ortho position, this carbon. Can this nitro group absorb these electrons? Yes, it have this capability. How? Like this. This is the point where nitro group is going to increase the acidic nature of phenol. Because this nitro group is absorbing the electrons which were coming from resonance, so that's why we call it is showing minus R effect. Due to this minus R effect, you can check the next structure will be you can check I am drawing these shared electrons very close to the oxygen. The next case will be this. Electrons will come here and nitrogen electron is going toward oxygen because oxygen is more electronegative. So around nitrogen vacant orbital will generate which will be satisfied with this lone pair. So double bond will generate here between carbon and nitrogen. And because this oxygen is getting extra electron of the nitrogen, so it will carry -1 charge. And obviously 3 pairs will be there, draw by yourself. So don't you think due to minus R effect, this timing of resonance, I will use this word, the timing of resonance or duration of resonance is increased. Means oxygen has shown this resonance due to which pi electrons were shifted here, due to which these electrons comes more closer toward oxygen. Now nitro group is just increasing the timing of that resonance by absorbing these electrons. This is the main point. Substituent from ortho position by its minus R effect is just increasing the duration of the resonance, due to which these electrons will remain close to the oxygen for the longer period of the time. This is the point. Substituents with minus R effect due to absorb of electrons which were coming from resonance are increasing the duration of the closeness of the electrons more toward oxygen, due to which the bond will become weak. As you know, the electrons are going toward oxygen, the bond will become weak. So don't you think this bond will remain weak for the longer period of the time? Because nitro group is enhancing this time period by absorbing the electrons which were coming from the resonance. That's it. This is the main point. After that, you know what will happen? This oxygen will take part in a resonance. Further movement. After this, you know, normal resonance you have to draw it. And again electrons will come toward this oxygen, and these electrons will go again toward hydrogen. So just minus R effect is increasing the time duration by which electrons will remain close to the oxygen. Which electrons? Oxygen, hydrogen, shared electron, due to which the weakness of the bond will remains there. Can this effect decrease, can this effect help to increase the acidic nature from the meta position? Let's check. Now I'm writing NO2 group on meta position. So let's draw the resonance. Now due to positive charge, these electrons will move little close toward oxygen. Means the bond becomes weak. But let's check, nitro group is helping somewhere to keep it weak from the meta position? The answer is no. You can check. When it is present on meta position, it is not getting electrons because electrons are not coming on the meta position. They are passing through it. Means from meta position, this nitro group is not able to show minus R effect. Can it show minus R effect from meta position? Check. Electrons are not coming from on this carbon, and if electrons are not coming on this carbon, it is not going to absorb them. Means from meta position there is no minus R effect from nitro group. And if there is no minus R effect, means it can't increase the acidic strength of a phenol from meta position. But if you will draw it on a para position, definitely you will get electrons, and you will find nitro group will be able to absorb those electrons. Try by yourself. Second way to check it is check stability of anion. I am now going to apply second method. Let's release H positive ion. Check, I have released H positive ion. I had made an anion there. Anion is unstable. You can check negative charges there. Can it be stabilized? Yes, due to resonance. Now again you can check. Okay, negative charge is finished because electrons will go here and one electron will completely transfer toward carbon, so negative charge is finished, and lone pair will come here. Now again you can check, this nitro group will absorb these electrons because it have this capability. These pi electrons will shift. One extra electron will go to oxygen, so negative charge will generate. 3 lone pairs will generate. Nitrogen always in the condition of +1 charged. Now don't you think due to nitro group the timing of a negative charge here is decreased? Look, due to resonance, oxygen's negative charge was finished. Here oxygen do not have negative charge, this carbon have a negative charge, so don't get confused. Here we have. Now you can check, after absorbing the electrons by a nitro group, the duration of a finish of a negative charge on oxygen is increased. So nitro group is just helping it to decrease the negative charge. Check. Already negative charge was finished due to resonance, and those electrons were further absorbed by nitro group. Means nitro group is helping to decrease the negative charge of the oxygen. And after that, you know what will happen. Next point, next movement will be this. Keep on drawing them. Here double bond will come, because now this oxygen will deliver 2 electrons for the bond formation here, and negative charge is not there on oxygen. Means from ortho position, the nitro group is absorbing electrons and it is helping to decrease the negative charge of oxygen. Means it is making it much stable. And as you know, anion will become stable, its acidic nature, its main compound acidic nature is increased. Means the compound who has created this anion, this was that, this one. So this compound knows that after loss of H positive, I will get this anion which is getting stability due to resonance, and nitro group from ortho position is helping out. Okay, can it help out from meta position? The answer is no. If I have this anion, let's try to stabilize. Okay, resonance is stabilizing it. You can check, negative charge of oxygen will finish and that charge will come on this carbon. It will come here and it will come here. Means again electrons are not coming on meta position, so nitro group can absorb it. Check. Means the negative charge of oxygen is finishing due to resonance, but there is no role of nitro here. Nitro can't help it by absorbing the negative charge or by absorbing the electrons from the resonance. Or I can say, from the meta position, nitro group can't show minus R effect. From para position it will do it. You can check it, try by yourself. So the conclusion is minus R effect of substituent will be operated from ortho and para positions, due to which acidic nature of phenol will increase. Now in next videos, we are going for compare the compounds. Different compounds will be in front of us. We will try to compare their acidic nature. There I will directly apply these effects, plus R, minus R. I will not open the molecule. I will not explain everything because I have already done. So directly I will use them, plus R, minus R, plus I, minus I. That's it. Thank you very much for watching the video.